So far, all the instructions we have learned uses a direct addressing mode. A direct addressing mode means the address is explicitly stated in the instruction. So the load instruction, for example, first 4 bits is RP code, and then remaining 12 bits we specify address X. So address is directly specified in the instruction. That's called the direct addressing mode. But another way of doing so is indirect addressing mode. Indirect addressing mode is that the address of address is given in the instruction, not the actual address. So location of the address is given in the instruction. So in C++ terminology, it's similar to pointer. There. So let's study more instructions which uses indirect addressing. So first one is a JNS instruction. JNS is store the current program counter at address X and then jump to X plus 1. What it does is as follows. Suppose I have a JNS instruction at this moment with 1000, for example. Then currently this instruction is at address 5, suppose that. And then at address 1000, what will happen is as follows. Store the PC. So if current instruction being executed, the JNS is at address 5, then PC is storing the next instruction, which is 6. So 6 is stored in PC at this moment. So store PC at address X 1000, store PC, which is 6, and then jump X plus 1. So here is the next instruction 1001. So whatever it is, so instruction jumps there, so program execution continues like that. The purpose of JNX is to define a subroutine or some kind of function, sub-program is there. So the idea of that JNS 1000 means the current next instruction to be executed is stored there, but jump to the following one. So this part is a kind of a sub-program or sub-function. And then once you complete this one, you can go back to where you were left off after this one. That is stored in here. So using this information, when your sub-program is done, you can jump there, then program execution. So it's similar to calling a function. If you call function 1 and so on, then function 1 is down here. So function 1 code executes, and finally it returns after the function 1 there. So using JNS, we can simulate that environment. In later section, later video, I'll show you the example how to utilize JNS to define a kind of sub-program. And the clear is a very simple instruction. So accumulator gets 0 value, like a reset accumulator. And then add ix is you can add indirectly. The add we learned previous was that the accumulator and then whatever is at address X is added together and stored in AC. That's the one. Add the I is then the of course the accumulator is one of the two operations for addition, but the other operation is not at address X, but at address X you have a address of the data. So what you have is actually address X is there. So that's something like this notation. So as you go to at address X, that's the address of the data you read from the main memory. So that's add indirect. So in this here, X is indirectly specifying the location, not directly, because as you go to X, you will find the address there. And then jump I is the previous one was a jump X. You jump to X directly, but jump I x is that you go to address x and then use the value at x as actual location. So if you go to x, you may find some data, for example 5,000, then jump to 5,000. That's a jump I. Here are the rtn notation for that. So JNS current address is stored at X. So to do so, PC is on MBR, and then X is in MAR, then whatever is in MBR, which is a PC, is stored at memory location. So that's the one. And then X is on MBR, and then AC is 1, then AC gets AC plus MBR. So X plus 1 is computed. X plus 1 is loaded into PC so that you can jump to X plus 1. Clear, it's very simple. And then add the indirect X is that X is loaded into MAR. And then using that one, you read whatever is in memory, MBR. But that one is the actual address to read. So that is loaded into MAR again, and then from that location we read the data. So that is to be added with the accumulator. And then jump indirect is X is used as address, and at that address we read the data, and that data is loaded into PC, so we jump indirectly to that location. Then we have two more instructions, load I and store I. So load I, as the name implies, we load not directly from X location, but the X is address of the value to be loaded. So what you load into AC is not just the memory address X. This was a load X, load X1. Load I is this one is address. So what you load is memory and memory X. This is the one indirectly. That's a load I. Store I is the other operation. Into memory, whatever memory X is, then AC is stored there. So in the rtn notation, load the indirect is that the X is used as address to read the data, and that one is actual address. So that one is actual address to read from the memory. Then that is stored into AC. Store I is the opposite operation.